This brief lesson is going to be about problem solving. We're going to go over 4 basic ideas about how we solve problems. It's not going to be anything too complicated, just 4 ways that we tend to approach novel situations and figure out the solution. So, when we look at problem solving, there are 4 basic strategies that we usually employ. The first strategy that we can talk about is trial and error. Sometimes when you are faced with a problem and you want to find the proper solution, you kind of just try out a bunch of different things and see what works. So an example that you could think of when you're trying to think of trial and error and what kind of serves as maybe a prototype for this would be if you had a bunch of keys and you needed to find what key actually opened a lock. By using trial and error, you would kind of look at all of the different keys you had. You would say, oh, maybe it's this key, maybe it's this key, maybe it's this key, and you try all of them into the lock until one of them finally opened it. So you go through all of your options and you just see what works. If you want to think of something that you also might have experienced yourselves with trial and error, I'm sure sometimes you've all had that experience where you're sitting at maybe like a math test and it's a multiple choice and you don't really know what the right answer is, so you kind of sit there and say, all right, well, I'm going to plug in each one of these options until I get the right one. So you try them all out and you see which one kind of fits. The second strategy that people tend to employ when they are solving a problem is using an algorithm. The definition of an algorithm is a methodical, logical rule or procedure that guarantees solving a particular problem. So the easiest example of an algorithm would be, again, a math-related idea, some sort of mathematical equation. Any single time you use an algorithm, you're guaranteed you're going to get the correct answer. Sometimes algorithms can be time consuming. Another example of an algorithm could be something like a recipe. Here we have a recipe for something delicious, so if you follow each and every one of these steps that's presented here, you will end up 100% guaranteed with a delicious s'mores cake in a jar, and so as long as you follow the steps that are set forth, you're going to arrive at the correct solution. So moving on from algorithms, the next strategy that you sometimes see used is something called a heuristic. Definition of heuristic is a simple thinking strategy that often allows us to make judgments and solve problems efficiently. So another way of understanding a heuristic is to call it kind of like a rule of thumb. It's a strategy for problem solving that usually works, not always guaranteed to work. It's kind of like a mental shortcut. So if you wanted to think of an example of a heuristic, maybe for some reason you need to know how many people go to FEEN. So certainly like an algorithm for finding out exactly how many students FEEN has. You could go and count every single person who's in the school building. You could go to 212 and ask for a list of everyone who belongs to the school. Or you could kind of sit there in class and say, well, I know, the senior class has 256 students in it, so multiply by 4, and that's about how many people go to FEEN. It's not going to guarantee you the 100% correct answer, but it's going to get you close enough. It's certainly going to save you a lot of time as opposed to going and counting every single person who's in the building. So heuristics are oftentimes going to be used more than algorithms because they tend to save us a lot of time. Now, if we were to compare and contrast these first 3 problem-solving strategies we've talked about, they each kind of have their own areas when they tend to be most useful. If you look at trial and error, usually that's best if you only have a couple of options. If we stuck with the example of trying out a bunch of keys on a lock, okay, that's probably useful if you only have about 6 or 7 keys. If you have 125, it's going to take a while. So trial and error can be useful, but it can also be super time consuming and not always the best way to go. If we're just comparing heuristics versus algorithms, heuristics certainly are going to be speedier, but they're also more prone to error. A couple of examples of heuristics versus an algorithm to solve the same problem. Maybe you have misplaced your keys. So you get home, you throw your keys down somewhere, you're not exactly sure where you've put them. The algorithm would say, all right, the only way to 100% find these keys is to make a grid pattern of the house, map out every single square inch and go through in a very methodical manner and search every square inch of the house. So you start at the front door, you work your way towards the back door, you have to search every single surface inside every single drawer. It's going to take forever. You're definitely going to find your keys, but it's going to take you a really long time. Now, if you were to use a heuristic, you're going to say, well, there are probably some areas where it's more likely I will find my keys. So instead of checking, in the lettuce drawer of the refrigerator, instead I'll check in my purse, I'll check in my bedroom, I'll check on the kitchen counter, I'll check the areas where I know I've been before I start searching all of the very bizarre areas. So heuristic versus algorithm, more likely to use the heuristic, but it's not 100% guaranteed to work. Another problem that you can use either a heuristic or an algorithm for, say you want to be sure you don't get a ticket for speeding. So there are a couple of different ways that you can ensure you're not going to get a ticket for speeding. The algorithm would say, well, make sure you never speed. If you never go above the speed limit, a police officer cannot give you a ticket. Now, certainly that's going to work, okay, but sometimes people want to drive a little bit faster. So a heuristic would say, okay, rule of thumb, as long as you make sure that you're not speeding in the areas where cops like to hang out, as long as you make sure that if you see a police officer, you slow down, as long as you stay within 5 miles an hour above the speed limit, then you'll be okay. It's not a guarantee you're not going to get a ticket, but it's a pretty good rule of thumb and a pretty good shortcut to solving that problem. Now, the fourth and final way that your book presents of problem solving isn't so much a strategy, because it's not something you can actively employ, but it is one of the ways we arrive at solutions, and this is through the use of insight. It is a sudden and often novel realization of the solution to a problem. So I am going to have you go and watch 2 brief video clips which show insight being used. There's a really famous psychologist by the name of Wolfgang Kohler, who is known for his research on insight. And Kohler worked with a chimpanzee named Sultan, actually. He had a name. And what he did in his famous experiment is he put Sultan in a cage and he put a banana just out of his reach. So it was through the bars. He couldn't reach it with his arms. Inside the cage with Sultan was a short stick. Now, the stick wasn't long enough to reach the banana. It was long enough, however, to reach another longer stick, which was also laying outside the cage. So what Kohler found was that, at first Sultan would kind of just wander around. He would try to get the banana. He couldn't. The stick he had didn't work. So he kind of was at an impasse. All of a sudden, Sultan had this moment of insight, kind of like an aha realization, and he used the smaller stick to reach the larger stick, which he then used to ultimately get the banana. So not only can humans use insight, but animals also can. So the 2 clips I'm going to have you go watch in a second are both showing how different animals can use insight. The first clip is, again, very close to Kohler's original work. The second clip is actually also Kohler, only this one is with a pigeon as opposed to a chimpanzee. And both of them are just showing very, very briefly what that moment of insight kind of looks like when, for no real reason, an answer just suddenly appears to you. So you can see here the 2 clips that I need you to go watch. It's up to you kind of how you choose to solve the problem of going to find these video clips. Certainly you can use either more of an algorithmic approach, and you can copy down the YouTube addresses exactly, go type them in, you're guaranteed to arrive at the proper destination, or you can use a heuristic and say, maybe I'm just going to Google the first couple of words in the title, double check that it's uploaded by the same person, and that should get me to the correct link. Either option is up to you, but just watch both of the clips, and this should give you a little bit of a better idea about what insight learning is all about.